Good morning. Good afternoon, everyone. My name is Tomasso. I am the CEO and co-founder of Entropica Labs. So it's great to be here. I would like to say my thank you to Kyun Kim and to all the folks at KQC at Korea Quantum Computing. It's great to join. Very happy to participate at this open house event. Today, I would love to introduce you to our work at Entropica Labs. We are a quantum computing software company based in Singapore, and our objective is to make quantum computers useful. So let's go into it. As I mentioned, I'm the CEO of the company, and prior to starting Entropica, I was working as a postdoc research fellow at SUTD here in Singapore and at the Center for Quantum Technologies. And even before that, I got a PhD in quantum information theory from Macquarie University. Actually, one of the reasons why I'm here today is because of something that IBM did. When IBM put the first quantum computer on the cloud in 2016, there was a big aha moment for me. It was the realization that the technology was becoming an industrially relevant technology. And especially at the time, it also offered me the opportunity to test a lot of the theoretical work I was involved with on a real quantum computer. And I spent quite some time discussing the potential and the opportunity in quantum computing together with Yuan, who today is our CTO and my co-founder. He was a PhD candidate at the Center for Quantum Technologies, and he shared a lot of the passion that I have and that I had at the time. And we were wondering how can we use our unique set of skills to help accelerate the process of making quantum computers useful. And the answer for us was to quit our academic jobs and start Entropica Labs in early 2018. And since then, it has been quite an exciting journey already. We've been working with some of the best quantum hardware companies, including IBM. And in March 2020, we raised a seed round of 2.6 million Singapore dollars with some of the best investors in the region, including the Singapore government via SG Innovate. You can see that there's a lot of milestones here. I will get back to some of them as we proceed. But first of all, let me start by sharing with you some of our thinking. Why do we need companies like Entropica? Well, we like to say because quantum computers are aliens. The reality is that it is incredibly hard to make them compute something at all. And it is even harder to make them compute something faster than classical computers. For classical computers, this is really not the case. Today, we have software interfaces, high-level languages. We have everything we need to communicate effectively with them. But with quantum computers, really is like trying to speak to an alien. The logic they follow is different, and the computational paradigm is very different from classical computing. So what role do we play as a company? What we do is building the software interfaces, which means the enabling layer to unlock the power of quantum computing. And our focus is on making quantum computers easy to use, accessible, and ultimately useful. This is what we do at Entropica. Something very unique about our way of working is what we name the hardware-driven approach. It really means thinking about the quantum computing experience from the bottom up. It means starting with the devices, using the quantum computers as much as we can, understanding what are the unique features of the different platforms, and also understand what are the limitations of the platforms, so that we can use them in the most effective way. And from the very beginning, we've been collaborating with superconducting quantum computing companies like IBM and Rigetti, and we've also worked with trapped ion devices like IonQs, and also Honeywell's quantum computer. Now Honeywell, as you might know, has joined forces with Cambridge Quantum, and the new company is called Quantinum. But especially when we extensively use their devices, they were still branded Honeywell, and this is why I'm using the logo for this presentation. We have tens of hours on these machines. In fact, we spend hundreds of hours running quantum computations, which is incredibly exciting having that opportunity. And it has made us very knowledgeable in terms of using the devices and also understanding what is going to be needed as we progress. And what is the aim of our work, right? In very practical terms. Well, for us, it's all about removing complexity. And as you can see here, there is a bit of a ladder happening. So up until last year, it was about removing the complexity of testing with quantum computers. But we are now past that phase. The phase that we are into right now is the experimentation phase. So we say removing the complexity of experimenting with quantum computers. And the next stage will be about removing the complexity of working with quantum computers and going all the way to generating value with quantum computers. This is how we think about our work, right? If you're a user of a quantum computer, we want to make it as simple as possible to use the device without having to worry about the complexity, for example, of the physics or the unique features of the modality that you might be using. Okay, that's nice to say, but how do we implement this vision in practice? I think the best way, as always, is to share experiences, is to tell a story, right? So we started in 2018, we were using a handful of qubits. And here you can see some code I had at the time. This code I've written is, I know is not great, but I hope you can appreciate the effort at the very least. And if you can read the comment, I hope you can, what the comment on top says is that the tricky part now is to write down correctly the unitary of the computation. Why? Because at the time, this was on the Rigetti device, and it says nothing about the Rigetti interface specifically. This was the case for any other machine available at the time. We were still thinking in terms of single unitaries, initialize a register, perform Adamar gates, perform rotations, and so forth. Well, the barrier with quantum computers was really thick then. How did we proceed from there? But before I move forward, I also want to emphasize that our focus at Entropica is on optimization, specifically combinatorial optimization, and how we can use quantum computers to solve optimization problems. And the algorithm or the family of algorithms that we have chosen as a main focus is QOA, the quantum approximate optimization algorithm. Sure, most of the people who are listening to this talk are very familiar with it, but if you're not, it is a variational technique that you can run on today's quantum computers, which is great because it gives you a very valuable testing ground. And it can also be used to solve optimization problems. Okay, so let's go back to our journey, right? 2020, we're using more qubits. As you can see, we're taking a more algorithmic approach to, in this case, building QoE techniques. Here specifically, we are not using 12 qubits, but this was the average of the qubits that we used at the time. And you can see that we're already thinking about, returning QASM code and not having to code unitary by unitary. We got smarter here. Starts to look a bit more Pythonic, if you like. But also today, we can use up to 80 qubits. This is what we have access to. And we have open QoA. The barrier has been removed, and now we can talk to the alien. We can talk to the device. You will wonder, what is open QoA? It is a Python library for optimization with QoA and its variations on quantum computers and simulators. This is timely because the archive paper just came out a couple of days back. OpenQoA is available on GitHub, so I strongly encourage you to go and have a look at the reference, and you will find links to the documentation and the GitHub page. It's open source, so all of you can start using it and have fun with it. And it already integrates with IBM's, Rigetti's, and AWS brackets available gate-based devices. And we are now working on implementation with Microsoft Azure as well. So why do we need an SDK, which is OpenQoA, right? Why do we need a software development kit? Because ideally what you want to do is to create and run QoA workflows with 3 lines of code. And this is exactly what you can do with OpenQoA today. You define a problem, which is something you don't see in this slide. You initialize a model. You compile the problem instance onto the model, and then you optimize, and you are done. It's very powerful. It's a great way to quickly and seamlessly experiment with quantum computers on optimization today. And why did we build it? Well, because running variational algorithms for optimization problems, or more in general, requires a lot of effort. And now we're giving you some of the insights on the kind of effort that you need to really give to this kind of work. You know, you need to set up optimizers to update the parameters. If the QPU connection breaks off over the network, this is a problem because you're going to lose all the data. You might have to rewrite the entire circuit if you want to run it on different hardware, and so forth. So the great thing about OpenQA is that it solves all these problems for you. So you can actually spend your time focusing on the problem that you want to solve, on experimenting with quantum computers. You don't have to worry about all the subtleties that happen in the background. It goes back to our aim, right? We want to make it as easy as possible to experiment with quantum computers today. And here is a short example, just a snippet of code for you. If you want to solve a number partitioning, which is a very well-known optimization problem, where you have a list of numbers and you want to separate them or label them so that the sum of the numbers in the two partitions is either equal or as close to equal as possible. Well, all you need to do is to define your problem statement, then import a class, in this case, the predefined number partition class, write the QBO form of the problem, then create an object, a QA object, compile, optimize, and get the results. It's incredibly quick to set up a problem and solve it using QoA with OpenQoA. There's more, of course. There's a bunch of useful utility functions. For example, if the problem is very small, you can brute force the solution and have a look at the ground state of the Hamiltonian, so you can compare the solution that you get with the theoretical solution. Of course, this can only be done on a small number of qubits, but it's a very useful tool if you want to start benchmarking whether things are working as they should. It's very easy to retrieve optimization data. And what OpenQA gives you is a very extensive collection of information about the whole optimization routine that you have run. And you can also plot the optimization history, so you can actually see how the cost function has been evolving with the number of function evaluations. So the idea here is to give developers a tool that gives a more comprehensive experience when it comes to solving optimization problems using QoA on quantum computers and simulators. About that specifically, it's very easy to switch between different simulators. Here we are using the Qiskit QASM simulator in this example, but there are quite an extensive set of local simulators supported, including Vectorize, which is Entropica's own simulator for QoA. It's a very fast one. But if you want to transition to a QPU, it's incredibly easy as well. You just need to take all the information about your account, and here we're using the IBM Q account as an example, and then continue as before. It's actually a really powerful way to work. And as you can see, you don't really need to change a code. You just need to change a line, and you're good to go. Our encouragement, of course, is go and try it yourself. So there's multiple example notebooks on the GitHub repo. You should go and try it out, leave comments, interact with us, really let us know what is missing, what you would like to see. We're here to help. We are here to nurture the community. And if you want to give us direct feedback, we actually have an OpenQA Discord already live. This is the link. I am afraid since there's a presentation, you will have to copy paste it and join it. Otherwise, you can reach out to us and we'll be very happy to direct you to the Discord channel. Okay, I think I was a bit faster than the 20 minutes that were given to me. Hopefully you will be grateful for that. Again, thank you so much for the invitation. I hope I managed to give you a nice overview of the kind of work that we do at Entropica. As I mentioned, we are based in Singapore. We're a team of 13. Our focus right now is on optimization and building software interfaces to make your work on quantum computers as useful as possible. Here you can see my contact, the company's contact, and if you want to get in touch no more, all you have to do is to write us an email. Thank you so much and have a great day. Enjoy the event.